Alright, so we got up to here, didn't we? Similar areas, similar volumes. We're definitely at the point of the course where these kinds of things sometimes come up, sometimes they don't. Okay? So just be aware that even though you're having 4 hours of exams, they're not necessarily going to be able to cover absolutely everything that we've taught you. Okay? So similar areas. We've looked at shapes being enlarged. We call that, what do we call how much bigger it is? Scale factor. Now, what we do is we normally assign that scale factor the letter K. Have we assigned that before? No. Why it's K, I don't know, because that's also what we use. What do we also call K? Yes, nice. The constant of proportionality. They obviously, mathematicians clearly like the letter K. Anyway, right. So let's look at the situation. Here we've got one rectangle, two rectangles. What's the area of this rectangle? Please tell me you don't have to find the area of the rectangle. 12 centimeters. Oh, we don't know what the units are. So it's 12 units squared. Yes? What's the area of actually, first things first. How much bigger, or what's the scale factor from A to B? 3. Yes? How do we know that? They're all 3 times bigger. Yes? So we choose one of our lengths, so maybe 18 over 6. And we know that the value of the scale factor is 3. So the area of this bad boy is 12. Is the area of B going to be 3 times bigger? Probably not, seeing as I'm getting you to look at it. What is the area of the big one? 6 times 18, which is 108. Yes, you want to with that? So, is 3 times bigger? How much bigger is it? What's 108 divided by 12? 9. So it's 9 times bigger. Ah, what's the connection? It's the scale factor squared. Okay? So the area is not multiplied by k, but by k squared. So let's just clarify here that 9 is 3 squared. So the area is going to be multiplied by k squared. So a similar situation with the unit conversion comes to similar shapes. Okay? So if a shape is twice as big, it's going to be 4 times the area. Here we go. We've been told here that this area is 5, this area is 80. Okay? We're trying to find a missing length here, so we need to find the scale factor. We can't find the value of k straight away, but we can find the value of k squared. Okay? So the value of k squared, how would we do that? Pardon? Not 5 divided by 2. How much bigger is this compared to this? The area. Divided by 5. Yes, you will get that? So we need to know how much bigger the big area is compared to the small. And that is going to give us the value of k squared. Are you all happy that that's giving us k squared? Yes? So what is 80 divided by 5? Almost. 16. We're getting good. We do have calcs. We can use it. Okay? So if k squared is 16, what does that value mean the value of k is? 4. How do we get that? I'm just checking. I know it's early, but we're getting a lot of responses, yes? So if we know k squared is 16, then we would square root it to find the value of k. So we know that the bigger shape is 4 times, or all the length of 4 times in size. So therefore, how would I find the value of x? Yep, so we would do 2 times 4, which is 8 centimeters. Good with that? Yeah? Standing leg sizes.
Why did we do the 2 times 4 like that?
Because the information they gave us was all about area, the changes in area. Okay? So, but they've asked us to establish a change in length. Okay, so we need to know how much bigger is that shape. So we look at the areas because that's the information they've given us. You can only find scale factors or scale factor squared when they've given you 2 numbers. Okay, so they've given us two values for the area, so that's enabled us to find k squared. Then we had to find k because this is length. And we know that length, we just need to know the basic scale factor. Okay, so this one's 2, we know that one's 4 times bigger, so we would say that that one's k. Does that make sense, Anna? Okay. I'm sure that you are not going to be surprised with what we get here. Okay? And the scale factor for length is k. The scale factor for area is k squared. We're going to find the scale factor for volume. So similar situation. And how much bigger is this shape to this? Yeah? Twice? That's 3, that's 6. So our scale factor for length is 2. We need to find our missing length. So this measurement here is 2, so what would this one be? 4. And this one was 1, what's this one going to be? Okay. Do we remember how to find the volume of a solid? So essentially what you want to do for a cuboid is find a vertex and you'll multiply the 3 lengths that meet at that point. Yes? So you're going to do 3 multiplied by 1 multiplied by 2. What's that? And what's the volume of solid B? So how much bigger is the volume of shape B or solid B compared to solid A? What's 48 divided by 6? So it's not twice as big, it's not 4 times the size, it's 2 cubes times the size. Nice. As I said, I'm sure that you were not surprised by that. So the scale factor for length is k, and the volume would be k cubed. So this is a little summary. Scale factor for length, we call k. Scale factor for area would be k squared. Okay, scale factor for volume would be k. Okay? Oh my gosh, really, humour is not going well. But maybe it's just me. Alright, so the diagram shows 2 rectangles. They are mathematically similar. So they have told us they are mathematically similar. We need to work out the length of the large rectangle. So they've told us that this one's 5, that one's 8. So the first thing we need to do is establish what our scale factor is. So how do we find the scale factor? 8 divided by 5. Now, is that a nice number? No, but it doesn't matter. As I said to you, it doesn't have to be a whole number. And so our scale factor is 8 over 5. So how are we going to find this missing measurement here? We're going to multiply 11 by that value, yes? So 11 multiplied by 8 over 5 is 17.6. Mirror C. So please don't panic if you're not getting whole numbers, please. Alright? Notice I didn't even find out what this was as a decimal. It doesn't matter. I've kept it as a fraction. Okay? Right, B. Work out the ratio of the perimeters of the rectangle in the form 1 to n. This is going back to a ratio. As you can see, this question is bringing in a few things here. So, we need to find the ratio of perimeters of the rectangles in the form 1 to n. So we need to find the perimeter of, let's call them 1 and 2. So what's the perimeter of shape 1? 32. How do we get that? Okay, you're adding up all the sides. Just a reminder, I've seen too many people just add the 2 numbers that was clean, or even multiply those numbers. That will give you area. So what do you say was 32? What's the perimeter of shape 2? 51.2? No, C. we need to write that in the form of 1 to n. So what are we going to do here? Say again? I would suggest potentially, first of all, write it as a ratio. So I would probably write 32.51.2, okay? But you then are going to have to reduce this one to be a 1. And so we did that by dividing by 32. And so exactly as Jodie said, we would do this divided by 32. And what do we get? 51.2 divided by 32. 1.6. You're thinking, it's not us, we never play yes. Yes, that's what. So you will, hopefully you will notice that this is 1.6. I don't know if any of you did actually find out what this was. That is actually 1.6. So your perimeter, because it's a length, is going to be in the same ratio as your enlargement. Okay, so it would be the same as the scale factor. C, find the ratio of the areas of the triangle. Do we need to go through the whole palaver of doing this? And finding the area of shape A and the area of shape B and writing those ratio? Pardon? Well, we don't even need to do that, do we? What did we just say? That this value here will always be the same as K. So if we're trying to find the ratio of the areas, you're just going to square that number, aren't you? Yes? Does that make sense to you? I mean, you don't have to do that. If you went to go back to find the areas, you would find it's the same. But as a shortcut, we know that it's going to be 1 to 1.6 squared. I don't know what 1.6 squared is. 2.56. So that's 1 to 2.56. Hopefully you're happy with that, yes? Alright, next one. Diagram shows two similar triangles. The smaller triangle has an area of 24 centimeters squared. Work out the area of the larger one. So, we know the area of this baby is 24 centimeters squared. We can see that they are similar, and that enables us to find the scale factor. How do I find the scale factor? Start to get a bit more conversation going. I'm going to, oh no, I could. How do I then find the bigger area? What do I need to find first? Scale factor for area. So the scale factor for area would be what? Or how do I find it? K squared. Wow. I believe that Amory and Jada are the only two people in this class. So I'm going to square these babies. So that's 144 over 64. Again, that can be simplified. It doesn't matter. It doesn't have to be simplified. And so now how am I going to find this area? Somebody speak to me. I know this area is 24. How do I find this one? Pardon? Samantha? Yes. I know you're all sitting there thinking it, but why is no one wants to talk to me? I've been sent to commentary. 54. Oh, shush now. 54. Just 54. Yeah. There you go. Okay. Real painful lesson.
Wait, what do you mean that one?
I squared 12. Yeah. Right, similar thing here. Similar, oh my gosh, I just kept my funny. So the diagram shows two solid cones, they're mathematically similar. So the smaller cone has surface area of 64 centimeters squared. So as soon as you start seeing things with units that are squared, you know you cannot use K, you're going to have to use K squared. Okay? So we need to find K to start with. How do I find K? 9 divided by 6. This really is painful. I'm going to simplify this one. So it's 3 over 2. What do I then do to find the surface area of the larger cone? If this one is 64, I square this. So I'm going to find, k squared is therefore going to be 9 over 4. And the surface... 3 over 2, wasn't it? I squared this. I simplified it.
What, can you not do this and then you can just leave it?
You can totally leave it 9 over 6, yes. So you can go to 81 over 36. So you can do it. Or you can make it decimal. Surface area of large cone is going to be 9 over 4 multiplied by 64. Give enough time off, you know, just to write it. Oh, Alexis is looking at me.
Are you not going to square and then 4 and then multiply outside?
No, that is k squared.
Oh, right.
Remember, I use 9 over 4, you use squared.
Why is it 9 not 6? Can you do 9 over 6?
No, I simplified this to start with. So you could do 9 over 4 or 81 over 36. Did I confuse everybody? I simplified it.
Because the one problem is 64.
I hear you. I thought you did put it in a big circle. Obviously, but
Husband,
we're doing really well listening. I'm trying my best. So, you could do 81 over 36, you'd get the same value. Yes? Yes. So what's the answer? Hey. Oh gosh, that was me, not the board. I can't even say that. Alright, the two cones are made of the same material. The larger one has a mass of 1080. Well, they're randomly now talking about mass. Okay? Please, does anyone remember what I said to you yesterday? Yes. So remember that conversion? 1 gram, 1 milliliter, 1 centimeter cubed.
Cubit.
Okay? So what we're going to do is we need to know the mass of the smaller one. So we need to find the cubed. Ujma, what's it? K cubed. Yes, thank you. I guess clearly I was that this morning. So we need to find K cubed. I'm going back to my simplified version of 3 over 2. Are you okay with that? So I'm going to cube both of these two numbers.
K equals 3 over 2.
Okay, so why is it K cubed again? Because we know the connection between centimeters cubed and grams. Okay? When it was centimeters, we established the value of K. Because the two measurements they gave us were centimeters. When they started talking about area, surface area, they were in centimeters squared. So we needed to find the value of K squared. Now they're starting to infer that we need to look at cubic units. Therefore, we need to find the value of K cubed. Because they talked about grams. Okay? And we know that 1 gram is equivalent to 1 centimeter cubed.
So we have to take centimeters.
You have to know about cubic. You have to know the value of K cubed. What am I not saying well, people? Help me. Do you understand me?
Yeah.
Can anyone help?
Last lesson we did that, and we're one back to a private room, and why does it have to switch to something?
Because they talk about grams, and that's the only way that we can link them together. Because we don't know anything about the capacity of it. So we don't know anything about liquid in there. If they started talking about liquid, then we would also need K cubed, but that's because they're all linked together. Yeah? So if they talked about volume, then automatically we would know we would have to go to K cubed. But the fact that they talked about grams infers that we also need, we're looking at essentially volume because of that connection between them. Okay, these kinds of questions are coming up more often, and they are the ones that fox people because they forget about this thing here, and they start thinking, well, I don't know anything about the weight bit because I don't know what the connection is. Okay. So what would k cubed be? I'm going back to my simplified version. So 3 cubed is 27 and 2 cubed is 8. Okay, so I've got my k cubed value. The large cone has a mass of this. So how am I going to find the mass of the small cone? Good. So this time I'm not multiplying. You happy with that? So this time I'm doing 1080 divided by 27 over 8. Okay, because they gave us the mass of the large one.
So why are you dividing it?
Because they gave us the mass of the large cone.
Oh, so if you're doing it small and big, then you multiply.
Yeah. Now, here's the situation. It doesn't actually matter which way round you go, as long as you are aware of which one you started off with. Now, I've taken this as my original, and this as my new one. Okay, so I've established this as being, how do I get from this to this? Okay, so you could have we could have said that k was 6 over 9. And we could have done all of our question like that, but we would have been doing division some of the time and multiplication others. So for this one, because they gave us information about the bigger one, and I need to find this, I need to divide. Because I have established how much bigger this one is compared to this one. So that meant the multiplying from the small to the big. Okay? And that gave us 320. Okay? Grams. Cool. And they might have said that this was 1.08 kilograms, so you would need to make sure that you remember how to change units, which we all know because Grandma's house has done it about 14 times. And we're getting bored of talking. Stop. Alright. So the following, solids. Right, Alexa, now. I think she's erasing something. These are similar solids. We need to find the missing link. Okay. What information have they given us? For both shapes. Volume. Okay. So what are we able to establish? K cubed. So we would say that K cubed, Natanya, is what?
50 over 10.
50 over 10. Lovely. I'm hoping you are all able to simplify that very quickly. What's that? So K cubed is 5. Now, we need to find the different lengths. So what do we have to do to this number? Cube root it. Lovely. Now, I'm telling you, that was cool. The cube root of 5 is not a nice number. I don't know what is going on. The cube root of 5 is not a nice number. I'm going to leave it looking like that. Okay? Don't try and round things, because if you start rounding things, you'll get the wrong answers. So k cube root of 5 is this, so that is the value of k. So how do I find this? X? 9 divided by the cube root of 5. Okay, and again, this one is a dividing by, because we established that going from here to here.
I thought it was
No, so if I had known this smaller value and I wanted the bigger one, we would have multiplied. But because they've given us the big one, and we need to find the small one, that's where we're dividing.
This was
Again, we were given the big thing. I don't know what it is. It's a decimal number. Okay? I would imagine, I stole this from a textbook, so I could change the numbers. I would imagine in a test that, I would imagine they would have a whole number or a nice decimal. This one keeps going on. We rounded that.
I have a question.
Yeah.
How did you get that? Because I put in my calculator and I think it's the 3 now.
I'll come and show you how to cube root something in 1 second. Right, following solids are similar. Find the missing length. So what information are we given about on this? Be careful, which 2 pieces of information are we given? We're given area. Okay, so what information can we establish? K squared. And we find K squared. 40 over 10. Okay, now, you said 40 over 10, so you're going from the big one and to the small one. Okay, so this is our original. Okay, and so that's K squared is 4. So what's the value of K? 4. Square root 4, which is 2, yes. So what are we going to do to find this value here? Pardon? Divide by 2, so we're going to do 10 divided by 2, which is 5. Now, here's the situation, and this is something you just need to, Jaden, you know you're either going to be multiplying or dividing, yes? If you did 10 times 2, what would you get? 20. Is this going to be 20? No. Okay? So that's all you have to say to yourself. Does it look like it's right? Okay? You're either multiplying or dividing. Look at which one makes sense.
Have you done 10 over 20?
You could have done, and that's when you would have been then multiplying. Okay? So that's the difference. That's the only difference as to whether you would divide or multiply. And again, Emma, you would just look at your answer and say, whoa, that's wrong. Okay? We good? How many more plots? 2 similar cones have volumes of 4 and 108 respectively. Find the surface area of the smaller one if the larger has a surface area of 54. Okay, so they've given us what information for both cones? Volume. So we can establish K cubed. So K cubed is going to be 108 over 4. Okay, so what's the, well, let's simplify this maybe. 54 over 2. What's the cube root of 54 over 2? It's not a nice number, I don't think, is it? Oh, that's awkward. What's the cube root of 27? And so that's the value of K. But what information have they asked us to find out? A new surface area. So we don't need K. But we had to establish the value of K. Pardon? Because you are not going to know what K squared is unless you know what K is. So you have to go down to the K in order to then square it again. And that's why I chose this question to go through with you, because again, this is a common one that they might ask. Okay? And so we can now say that K squared is obviously 9. Now, I say that you need to know, maybe you would be comfortable saying, well, that's K cubed, I know what K squared is going to be. Okay, but most people would have to go down to the K and then just square it. And the larger one has a surface area of 54. So how do I find the surface area of the smaller one? So 54 divided by 9. Again, it's the common sense, is it going to be multiplied or divided? So their surface area is 6 centimeters squared. Okay? Right, I've got a worksheet for you.